All right, we have reached chapter 4, where we will discuss about browser and web application attacks, and this fits perfectly with our computer networks review, and specifically the top layer, layer 5, the application layer. The slides were taken partially from your textbook. As a source, I used the textbook chapter 4.1, and I also used the Stanford Web Security Group slides as a source. The short outline for this video. First, we're going to start reviewing the web security model, the adversaries, and the weak points of web security. Then we're going to dive deep into the browser attacks, and then we're going to take some specific examples of browser attacks, specifically ActiveX, JavaScript, and cookies and SOPs. Again, a little bit of layering so that you have a view of where the browser stands. Of course, the browser is an application with many rights, actually, that sometimes it shouldn't have, like accessing files and things like that. But to operate properly, it should have that, accessing directories, writing into them, and all that good stuff. The browser requests content from a website through a network, and the website replies. Below the browser, there's the operating system and the hardware, and the browser interacts directly with the operating system and indirectly with the hardware, of course. We talked about the hypertext transfer protocol already, so you should go back and view a little bit the details of this on the networking lecture, specifically the methods that are used to request and return data, get, post, and head, the evolution from 1.0 to 1.1 and what was added, some additional methods, and the fact that it is stateless. So each request does not depend on other requests, and that can have impact on its applications. Here we are dissecting the HTTP request. The first thing that we see is the method, the get method, trying to get a specific file. This is a .NET website, so default.asp points me to that. If you know some web programming, this helps you quite a lot with understanding web applications and the HTTP protocol. And again, if you want to be a security analyst, especially from the perspective of a computer scientist, not just policies and InfoSec, you need to know good programming, web programming, databases, and of course, application programming. So moving on, HTTP version is also there, the headers of this request, and then the data. That is, in this case, nothing for the get. And some information about the system, right? We've said that any information that we can gather, reconnaissance is good. What browser it's using, the languages it accepts, and so on and so forth. So get was a request to a web server, and here we have the response. The response, of course, again, we have the version, and what kind of response is that? If this is an error, we would have a different code, but this seems like this response has worked out, and we can get what we have asked. Again, some headers that give us additional information about the server and what version and what operating system it's running. And then, of course, in the response, you will also see the data, which could be HTML. And if you look at your Wireshark captures, you would see these kinds of data. So it's very cool. It's very interesting. You see content length, last modified for the web page when it was last modified. Lots of good information that you can see in this layer and that you have probably already seen in your Wireshark lab. We did touch on the concept of cookies also when we were reviewing about networks. So the cookie saves information in the browser about the session that is ongoing between the browser and the server, so that we don't have to send this information all the time. In this case, there is a domain that can read that cookie and handle it. It could be, something like cofc.edu, that's a domain. When the cookie expires, because we said they have to expire, and we will discuss about security issues when they don't. And then the nature of the cookie, like send this only over HTTPS for security and all that. So this field defines that. And as we discussed in the computer networks review, cookies add state to an otherwise stateless protocol. So what do we use cookies for? We use them to prove that the website that the client previously authenticated correctly. So authentication, we use them for personalization, to help the website recognize the user from a previous visit and use their personalized settings. And of course, for tracking, to follow the user from site to site, learn his or her browsing behavior, preferences, and so on. So that we've talked about the basics of the web browser and its protocol and remembered about cookies, let's see what are the goals of web security. First, safely browse the web. So a malicious website should not be able to steal information from you or modify legitimate websites or otherwise harm the users. So even if visited concurrently with a legitimate site, a malicious website should not be able to interfere with a legitimate session. So your browser has multiple windows, for example, or tabs, and if you're visiting a malicious website and a legitimate website, and in the legitimate website you're putting your password, the malicious website should not be able to access that password. So that's something that is a goal of a browser. And then supporting secure applications, that's the other part of web security. So the first part involves the browser. The second part involves the applications, the content delivery. So the applications that are delivered over the web should have same security properties that we require for standalone applications, whether these are mobile or PC applications. Here you see a little bit of a visual of what we said before about browser security. So whether you have tabs or multiple windows, it should be safe to visit two pages at the same time without one being able to compromise another one. And of course, safe to visit a website. So this is the mission of web security within a browser. Sadly, though, the biggest security vulnerabilities come from web applications, and that's of 7 years ago, but still the biggest vulnerabilities and number one vulnerabilities come from web applications. So things have not changed that much, unfortunately. So, as I have mentioned before, as I was analyzing the goals of web security, there are two sides, the web browser and the web applications. The web browser is responsible for securely confining web content presented by visited websites. And the web application is everything else, online merchants, banks, blogs, Google Apps, mix of server side and client side, and then there's going to be different technologies used over there. The server side code is written in PHP, Ruby, .NET, and runs on the web server. The client side code is written in JavaScript and runs on the web browser. And there are many potential bugs, cross-site scripting, SQL injection, and all of these good things that we will discuss in this chapter 4. So where do attackers live, specifically to web applications? Everywhere, unfortunately. On the browser, they can tackle the browser and its add-ons, plugins. On the operating system, they can go after the operating system to impede browser operation. And of course, on the network, when the adversary is sniffing the network. We will focus on the browser in this specific video. And again, going from the top towards the bottom, the web attacker, the network attacker could be an eavesdropper, passive or active, and then the malware attacker that would execute malware directly on the victim's computer to infect them. And of course, think about how a user would be convinced. I think most of you know already, to install malicious software in their computer. A few more details about the web attacker, who is a big part of the threat model of web security. For web security, the web attacker can even obtain certificates, like the secure certificates that you see with HTTPS, which this protocol, we call it SSL TLS. The web attacker can also phish the victim with emails and enticing content and place an attack over there, or it could even use a Facebook application or Facebook as a vehicle, or in general social networks. And the web attackers can also be using what you see over here, iframe, which is malicious content included in an otherwise honest web page, and it can include advertising and mashups. Of course, you never visit dangerous websites, I know, or you just think you don't. So there are Microsoft Web Patrol. That was an interesting project that would identify URLs that would try to exploit and patch the Windows XP machines. And then many of these URLs were interlinked, and or using redirection, they would get you to the malicious website. But yes, and even if you say that you never use a risky website, think twice, because do we really always check a URL? I mean, personally, I try to do that, but sometimes our guard is down, and this is when bad things happen. Of course, at least we have programs that try to secure our browsers and our computers, and of course, we have to be ever diligent, as we will discuss when we discuss about phishing, and confirm everything that is sent to us. Next, we will talk about browser attacks and their different flavors, and also how we can prevent those. Okay, so there's different attacks over here. The first one, man in the browser. So a Trojan horse that intercepts your data could be planted in your browser. One of the most famous one is the Silent Bunker, which even authentication can protect you from something like that. The Silent Bunker would intercept your data before it's encrypted to be sent to your bank through TLS. So a pretty bad Trojan, a pretty bad attack, devastating attack, because data that is sent is valid and authenticated, but then it's being intercepted by this man in the browser. The second attack is a keystroke logger. You may have heard of that in the concept of hardware, but there can be software keystroke loggers that could log your keystrokes, and they could come to you through your browser, through malicious sites. The third one is the page in the middle, which is different than the one in the browser in terms that you are redirected to another page when you have clicked on something that you thought it was legitimate. So something that could prevent that would be checking URLs continuously. Download substitutions can happen. Somebody could substitute a legitimate file with a virus. However, what saves us quite a lot from these attacks is that users are diligent, and also browsers scan and prevent these attacks from happening. And the user in the middle is an interesting one. You may have heard of CAPTCHAs that are used to avoid bots trying to log into websites and brute force things, or DOS websites. CAPTCHAs are these text that a bot cannot distinguish, but a human eye can. There's also the new reCAPTCHA by Google, which is just a click, which is using intelligence to see if you're a real user, and this intelligence is based on Google apps. By the way, there's not that much information about Google reCAPTCHA because Google is quite proprietary with everything it does. So the user in the middle is trying to pretend that there's a legitimate website. Well, not very legitimate, could have content, adult content that some people want to see, and then it may kind of fish them and say, oh, please solve this CAPTCHA so that you can access this content. And then through that, the bot is using the humans solving of the CAPTCHA to get into sites. So that's a user in the middle attack. So how do these attacks succeed and keep succeeding? Well, there is not much authentication. When authentication is not used, these attacks are prone to work. So the human authentication, which we talked about a lot when we were talking about cryptography and signatures and digital signatures and all that, and passwords, relates to something you are, something you know, and something you have. The computer authentication could be done through computer addresses and characteristics, and it's a little more difficult because the computer only saves things and only knows things. There's not an essence of what they are or what they have. So something that needs to happen between browser and server is continuous authentication. And of course, authentication is vulnerable to different things, such as usability. So if you want to make a usable site, for example, you don't want to authenticate all the time, or you authenticate every 5 minutes and so on and so forth. It also, computer-to-computer authentication is limited, as I mentioned before. There's only a stored key, not multiple ways to authenticate. And then, of course, there's malicious software that may eavesdrop and all of these things. So successful authentication could include a shared secret, a one-time password, or out-of-band authentication or continuous authentication that happens periodically or with some triggers. Now we will move to specific characteristics or programs or plugins on a browser that make it vulnerable, starting from ActiveX. ActiveX is a menace. It's a Windows software that resides on the client machine, and it's downloaded and installed like any other executable, and it's activated by an HTML object or tag on the page, and it runs as a native binary, not interpreted by the browser. So its security model relies on digital signatures to verify the source of the control, browser policy that can reject controls from network zones, and controls that can be marked by author as safe for initialization or safe for scripting. But once accepted, installed, and started, there's no control over ActiveX's execution. So it's being deprecated, and we're moving on away from it, but it's good to mention, the oldies but goodies of the vulnerabilities of the browsers. So here is the magic box of installing ActiveX, and then if you install it, you have no control over the code. And actually, as Microsoft says, it can do anything the user can do, ActiveX, because it has access to the local file system, yay, and any web application on the internet can repurpose it. So lots of rights for ActiveX, not good. So here I challenge you to think how a control can be repurposed. Once a control is installed, any web page that knows the control's class identifier can access it using an HTML object tag embedded in the page. So think about this can be repurposed for malicious reasons. Okay, so there's lots of vectors for attack for ActiveX, and that is why it has been phased out from browsers. So now it is time to talk about JavaScript. Before we talk about that, let's look at the basic execution model for a browser. So the browser loads the content, and you may have heard the expression renders. So it processes the HTML and displays the page, the content of the page, and of course it also processes scripts. And this it may involve subframes and all that. And the browser also responds to events. It's event triggered. Events can be user actions, rendering, on load, on unload, and all these render type of actions, and of course, timing events such as periodic or timeout triggered events. I'm pretty sure that all of you have seen HTML, and maybe you have even seen scripts. So this is a script, a JavaScript script actually embedded in the HTML. So the browser receives that content and displays the content and also executes the script. And here is another script execution that is triggered by an event, a button event. And then if this button is pushed, let's say, something will happen, like if it's button 1, and a specific alert is going to come up, and if it's button 2, another alert. So the next slide will show you the results of this, like before. So now we're discussing about JavaScript, the language executed by the web browser, the world's most misunderstood programming language, interestingly. So, to the point that people think that it has something to do with Java, which it really doesn't. So, it is used to implement interactive pages, and it can run before HTML is loaded, or before even the page is viewed, or while it's being viewed, or even when leaving the page. And it is a potentially malicious vector for attack to execute some code on the user's machine. As I said, a quite misunderstood language, even confused with Java, which has nothing to do with it. It's related to Java just in name. It was discovered a while ago at Netscape, and then was standardized for multiple browsers. And then there's various flavors of it, and it's pretty prevalent still in web programming, web application programming. We're obviously reviewing JavaScript when talking about web browser security because it's being executed on the browser side, on the client side. And it can add cool special effects, dynamic content, navigation, and it's really widely used in hundreds of applications, or probably thousands nowadays. You may have seen the script element in web pages if you have programmed a little bit for the web. And JavaScript can be embedded or it can be included as a script in an HTML page. And it can handle different events like mouse events, click events, and things like that. And it can even create pseudo URLs referenced by a link. The programming model for JavaScript is called the document object model, and it's a way of structuring the objects in an HTML page in a very neatly thought hierarchical structure. It's object oriented, and everything is part of a document in the document object model, and even the browser is part of these objects. The window, the frames, the history of the browser is part of this document.history, document.window, and so on and so forth. So a very neatly organized structure for JavaScript programming. Here I would challenge you to try to understand and reverse engineer how JavaScript works if you have never seen it before. So you see in the first example, we are referring, it will return UL because this is the document.getElementById .node name, where in this case the node name is UL, an ordered list. The node value, there is no value for the unordered list, so it's going to be null. In the third line, the first child of the node name is a list item, li, and it does have a node name, and that name is item1. So slowly but surely, if you look at this, you can reverse engineer what JavaScript is and how it works. And in the next slide, maybe you can guess how you could insert through JavaScript a new list item in this unordered list. So here we see the code on how to add the new list item. First, we need to find where to add it, and then we need to add this. So I would encourage you, I don't like to just review code and slides. You will have the slides to see it and try to understand exactly where we find, where's the spot to add the new list item, and think, is this going to be added after or before the item one? Next, we will look at a script stored by the browser as a bookmark. And I want you to study the next examples and again try to understand how JavaScript works and how it can be malicious. It's important to try to understand this on your own and maybe Google the resource W3C and see what each line of code means to understand why this can be malicious, and this must be executed only on the right page and not on a malicious page. So the next few slides describe a JavaScript rootkit, which I'm not going to get into details because I want you to try to figure out why this would be a rootkit, why this would cause damage, and how. And then there will be a small question in your quiz. So prepare for that in the quiz that is following. Finally, we will talk about cookies and some issues that we may have with these stateful objects. I have to say about the previous code. This you can gather questions and ask me. The question on the quiz is going to be fairly easy, so don't get upset. Oh my gosh, my grade is going to be jeopardized if I didn't understand this JavaScript rootkit that was in the previous slide. We will definitely discuss it when I get back. But think about it, because the best way to learn is to try to reverse engineer and decipher things, especially with code, on your own. Okay, the same origin policy or SOP for the DOM, for the document object model, says that origin A can access origin B's DOM if A and B have the same protocol, domain, and port. In other words, a JavaScript cannot access a text box of another site. So this goes to the safe browsing concept. And cookies are characterized exactly by this protocol domain port. And so they keep things separated this way, and one site cannot access another one. But bad things can happen, and even the same origin policy cannot protect safe browsing unless it's implemented properly. Back to the cookie jar and how cookies are set by the server, you can see that there's an expiration date for the cookie and then the scope of the cookie, which is defined by the domain and the path of the setting URL. So this is something important to keep in mind. Cookies will be identified by the name of the user, as you can see over here, the domain and the path. These are two different cookies, and both are in the scope of login.site.com. Okay, so the SOP for writing cookies. The domain can be anything, any URL, okay? Except, of course, for the top level domain, like just .edu cannot be a domain, okay? So you can see valid domains could be login.site.com or .site.com, but not the .com. The path can be anything, directory. I think I've shown you URL paths. Like if you access a document in my website, you will see the docs/docs path. So the path can be anything. So which cookies can be set by the loginsite.com, login.site.com, and .site.com, not the user or other site or .com. Just keep that in mind, super important for the SOP. Now, what's the SOP for sending the cookies? The browser will send the ones that are within the URL scope, and the protocol will be HTTPS if the cookie is secure. The domain is the domain suffix that was set, and the cookie path is the prefix of that URL path that is used. And the goal is to use cookies within the scope of the specific server. Okay, so here, look at these three sites and look that all of these are set by login.site.com because they are within the scope of this domain and within the scope of this server. Now the server, and that is really interesting, it doesn't see the cookie attributes and it doesn't see which domain set the cookie. So think about that and what could be the implications of the server not being able to see the cookie attributes. Okay, so the responsibility falls on who? The client. And here is where things can go south. Who sets the cookie? Okay, so Alice logs in to login.site.com. Okay, so this sets the session ID for the cookie.site.com. But now Alice visits the evil.site.com, which overrides the .site.com session ID cookie. And this is not an SOP violation, and you can justify why. Excuse me. Now, Alice visits the 361.site.com, and now this with the cookie that has been set from evilsite.com. Okay, so now we have the 361 site.com thinking that they talk to Alice, but they're talking to the bad guy. So the secure cookies is in quotes because cookies are not really secure. They were a way of implementing state for HTTP, and the implementation is kind of disappointing. There's no authentication on who sets the cookie and all that. So, but they were made for convenience and customization, like I said, and all these good things. However, cookies can be secure, quote unquote. Cookies can be overwritten, as you saw in the previous slide, and not even violate SOP. So this can happen with different ways. It can happen by getting phished and visiting a malicious website. And then setting a cookie through that malicious website, overwriting a quote-unquote secure cookie. So to recap what we have discussed about browser security, we discussed about the web security model, what are the vulnerabilities in web security, and then we drilled deep into the browser attacks and different flavors and why they work and how we can prevent those through authentication and proper continuous authentication. We talked about ActiveX, all these bad goodies. We talked about JavaScript, and we left the JavaScript rootkit for you to analyze and reverse engineer and understand step by step. And finally, we talked about cookies and SOP and how secure cookies can be violated and overwritten by unsecure websites and perform man in the middle or pretend to be you by using your session and your cookie.